Okay. So good afternoon, everyone. My name is Csilla Orgel, and I'm working for the European Space Agency at ASTERIA in the Netherlands. And today I'm going to talk about a proposed payload for the Lunar Gateway. It is a science payload, and it aims to measure dust at the gateway's orbit, and also reveal some interesting science questions about the interstellar dust in the early 2030s. So we know that there's a continuous flux of micrometeoroids in the Earth-Moon system at 1 astronomical unit. And this dust has various origin. So interplanetary dust, which is from asteroids and comets, interstellar dust, which is coming from outer of our solar system, lunar dust ejected by natural processes from impacts, and also when human activity and robotic activity will be more common in the to the lunar surface, then we will have to deal with uplifted lunar dust and also anthropogenic debris between the gateway and the lunar surface. So ASTERIA, that's an acronym. It stands for Active Sensors for Telemetry of Extraterrestrial Impactors at Gateway. And this is an ESA leading activity and should be deployed externally on the gateway. And it will measure all of those various dust populations at the gateway's orbit. So understanding and monitoring the dust environment will help us to safely explore the lunar vicinity. And also the gateway provides a very unique platform to observe interstellar dust, which will have which has like a every 22-year cycle, has probably something to do with the solar cycle, and then the early 2030s will provide the time to observe this interstellar dust. So interstellar dust, as I mentioned, it comes from outer of our solar system, has to do something with the solar cycle, and then there were previous missions who observed this interstellar dust, so like Galileo, Ulysses, Nozomi. And also there were candidate grains from the Stardust mission. There is an international facility definition team who is defining the science for ASTERIA and also provide input for a phase A/B industrial development study. So their task is to define the exploration science goals, sub objectives and research questions, and also assemble a science traceability matrix with measurements and performance requirements for ASTERIA, and also define the operation requirements for the payload. We have regular tag-ups, and also we so far had 2 in-person meetings, and we will publish the results soon. So just a couple of the science questions we try to investigate. So to determine the natural flux of lunar dust at the gateway environment. That natural dust comes from impacts to the lunar surface, and the material is diffusely present at the lunar orbit. Also, we would like to monitor the debris generated by activities like launch vehicles, which come back to the gateway from the lunar surface, or other debris generated by the gateway. Also, we would like to investigate comets and asteroids through studying the already known the dust streams at the Earth-Moon system, and also understand the origin and evolution of the solar system. We also find interesting to study the dust and heliospheric interaction, and also how the interstellar dust is interacting with our solar system and could provide implications for interstellar dust and extrasolar systems. So in order to address those questions, we need to measure things. So to determine, for example, the flux of the dust, we need to measure the number of flux over time. We need to know the size and the mass of that of these particles. We want to determine the origin of the dust, and therefore we need to precisely know the trajectory, the speed and composition of those dust particles. And also we would like to get to know more details about parent bodies. So therefore we need composition and structural information from these dust grains. So some of the key findings from the exercise so far is that ASTERIA can address unique science across multiple disciplines, planetary science, space environment, and heliophysics. We also found out that the active in situ measurement and sample capture would be both needed to answer this, to address the questions. However, it is not feasible for us to put together an active and a passive collector due to the gateway payload envelope constraints, so mass and volume. So in this study, we focus on the active payload part, which will be a core instrument will be a dust detector, and we will provide also one or two opportunity for additional sensors. And then therefore we also look for international collaborations. So what are the next steps? We actually about to finish the final report, which will be issued end of this month. And then we are preparing a peer-reviewed publication. And at the end of the year, we will have an invitation to tender. So for a phase A and B study. And after that, we will start a phase AB then early next year. Thank you, and thank you for listening.
Thank you. That was actually quick. So we might have a couple of interesting questions. Any questions? No? Let me start with a dumb question. I'm just wondering whether these types of sensors can also detect also can distinguish whether the dust is erupted or on the surface. Is it possible?
So we would detect dust at the gateway. So the payload is on the external part of the gateway.
So it's not on surface.
It's not on the lunar surface, but if some impacts are big enough to eject material to the gateway orbit height, then we can detect those particles. But we also expect that all these launch vehicles coming from the surface and docking to the station, they will also lift some dust with them, and we don't know the impact of that.
If you can do that, that'd be great, because we're always looking for the surface activity stuff.
Yes.
That's great. Any other questions, please? Okay, from online.
Oh, that's great. Thank you. Oh, the bottom. Okay. When it comes to observing interstellar dust, how much difference do we expect there to be between aboard the ISS and aboard the gateway? Are observations from the ISS sufficient? Oh, I cannot read. There is a message on top of the text. Oh yeah, now I see.
That's it.
Are observations from the ISS insufficient? So I believe that the ISS is already in a very contaminated area. So for us, observing in a pristine environment, so for now it's still pristine. We didn't have much activities around the moon, so we have better chances to observe interstellar dust than from the gateway orbit than from the ISS.